Okay guys, I'm back at it again. I have another Betamax. Seems to be that this is the Betamax week for me, right? But this is another one. And this one here is an older one than the last one that had the bad video. This is actually I think this is a 3-head machine. So it had good slow motion and good pause. This is what they call a Beta Hi-Fi Ready. So this is one of the HFR series. So it had, it didn't have the stereo circuitry to record stereo sound built in. There's actually a plug on the back here for plugging a Beta Hi-Fi processor. That was another one of Sony's brilliant ideas. Let's make a hi-fi machine without the hi-fi circuitry, so that if somebody wants to spend another couple $100, they can buy it. Okay, yeah, they had some pretty good, brilliant marketing schemes, I tell you. Okay, let's see what happens when we load the tape on this. As you notice, this one's a different loading mechanism. It's got a belt drive for the loading mechanism. Other than that, the threading is the same. It's just a different. This one's got a solenoid in here that drives it, and it uses a belt, as opposed to the other one was gear driven. This one is belt driven. Okay, well, the tape is loaded. That's a good sign. What happens if I press rewind? Oh, I already noticed what's going on here. The head drum's not turning. Look at that. The head drum is just sticking in one spot. We have a motor or servo problem on this one. Yeah, it's definitely got a problem with the drum motor. It's stuck in one state. The capstan and the drum motor, these are a 3-phase motor. It's a DC motor, but these are operated as a 3-phase DC. So there's 3 coils that are controlled by a controller IC. And there's typically a signal that's generated by a little Hall effect device that tells it what state the motor is in, so that it knows which coil to turn on next. We're going to disassemble this unit and take a look at that. There's something in the motor drive. It could be the drive IC itself that's gone, but it may not be. It may be something totally different. So let's investigate and see what's going on this. Now, I remember from years and years ago, there was a problem on, I think it was the SL2400 series of Beta machine that Sony had, where they poured some glue onto one of the circuit boards that held a little Hall effect device, and that glue, when it deteriorated, became conductive and shorted it out. And when that signal wasn't there, the servo or the drive IC didn't know what state the motor was in and didn't provide it with the drive signal to spin it up. And it's going to be, well, it's going to be on this board here, I think. That's where it's going to be. This is your capstan motor. As you can see, compared to the other Beta machine, this one actually has a separate motor for the reel. So this one's got a reel motor, a direct drive reel motor, a direct drive capstan motor, and a direct drive drum motor. The other machine, if you remember, it only had a single motor for the drum and a single motor for the capstan, and it had a belt that drove the take-up and supply reels. Well, this one here, this is an older generation. This one actually has a separate motor to control that. I'm looking at the drum motor here. This is the one I got to get a look at and see. I believe that Hall sensor is underneath this magnet, underneath this rotor, so I got to take this off to take a look underneath it. Even without pulling the drum apart, I think we can see the problem right here. This is the Hall sensor. And you see that crap that's in there? That looks like dried up glue to me. I think this is our problem. We're not getting a signal. As the drum starts to rotate, it's the magnets on the motor create a voltage on the hall sensor to tell it that the drum is turning, so that the circuitry that controls the coils can switch to the next coil to cause the drum to spin. And it doesn't get a signal, it doesn't know what to do. And I remember a while ago, now this is 20 years ago, we had this problem with these things. It looks like it's cropped up on this one too. It looks like it's going to be just this glue that's gone bad that we're going to have to clean out. I still got to take this rotor off though, because I want to be able to get in there and actually clean it properly. But that's what we're looking at right here. So this hall sensor is gummed up. Just for the hell of it, I'm going to try and just scrape this stuff out first with my dental pick. Just see whether we can clean this out before I pull the motor all apart. So we're just going to take the nut off here and take the base of the drum, the magnet assembly off, and take a look underneath here. Should be able to just pop this up now that it's loose. Get a couple screwdrivers in here to pry the magnet away. Okay, now the magnet's off. You can see this is a strong magnet, so you want to keep it away from anything that may stick to it, because if you get any filings or anything on here, that's going to cause a problem when it goes back together. Also, don't put it near tapes, it'll erase them. So I'm just going to set this out of the way where it's not going to get dirty. And now we can inspect the Hall effect device, which is right here. As you can see, if you see the coils here, right? You've got 6 coils. It's a 3-phase motor. So the drive IC switches the current from one coil to the next, 2 coils at a time. So it'll energize those coils, and then those coils, and then those coils, and it creates a rotation. And it determines what coil to energize next based on the signal fed back from this Hall effect device. And what happens is glue that was placed in here when it was manufactured deteriorates and becomes conductive, shorts it out. So we just want to clean out where the Hall effect device goes and clean the wires off. And hopefully the device itself is okay. If not that, it could be the drive IC itself that's at fault. But we'll just clean this out first and see whether that will solve the problem. In this case, it doesn't appear to be the glue that's causing the problem, as I cleaned it up and it still doesn't want to spin. So the next thing we're going to do is we're going to actually pull the drum so I can take a look at the other side and make sure that the solder connections for that Hall device have not failed. So we removed the drum by removing these three screws that hold the drum in place, and we'll undo the connector. This is for the head amp, because the rotary transformer and everything comes out with this. So we just have to unplug the head amp. Line goes. This is it here. Should go back to a plug over here somewhere. I believe it's that one. That's one of them. And the other one is this line here, which goes over to here. And we just have to cut this tie strap that's in the way. So now we have the drum completely free, and we can remove it and inspect it. Gotta love Sony for the way they tied everything together. Makes it hard to get connectors and stuff out. There we go. That one's out. So we're just gonna take out this last screw. Put my hand below it to catch it, so when I remove the last screw that holds the entire drum assembly in, then everything should just drop on out. There we go. These are all spring-loaded springs here too, which is kind of cool. Okay, the drum assembly now can be passed right through the chassis and out. No, can't. I gotta remove this clip on top here that's holding it in place. It's a grounding clip. And of course, as soon as I remove these, as soon as I remove this is going to affect my alignment. So, because there's a couple of little guides that lift out as well, and these here are part of the tape transport that will now have to be realigned, but I don't have much choice. That has to come out to take out the drum. So there's the head drum. You notice I'm being very careful as to not touch the heads with my fingers. And now we can actually look at the motor portion of this separate from the head drum. Nice thing about this is I do have a spare sitting here that I can steal this stator assembly from if need be. But we're going to check to see what's going on with this thing. So a couple more screws and we can actually remove the stator assembly from the video head drum. And that way we can get a look at the electronics that control the motor. So this part is the rotary transformer and video head assembly. We don't need to worry about that. We'll just set that aside. There's actually a sensor on here too. There's an FG generator that determines the phase of the head drum. This one here is just the actual circuitry that spins the motor. Since the motor is not spinning, we know the problems on this board here. It's either the drive IC that's gone bad, or maybe one of these little capacitors, or the Hall effect device is not communicating. So that's what we're going to look at, is the Hall effect device first. So upon further testing of the drum motor here, I'm going to change the entire stator just because I have another one. It is looking like maybe the drive IC has a problem. So an easy solution to that is, because I do have another complete stator assembly, which is the same as this part. The drum itself is different. This is the 3-head drum, but the other machine that had the bad heads was a 2-head machine. So we can just take the whole stator assembly and rotor assembly and just attach it to this other drum assembly. I just have to, I'm just going to pull it off here for a minute just to take that. I'm going to take off the actual magnet so that I can align it and then drop the magnet back on. Okay, so we'll take the magnet off and just set it out of the way. Just, that gives me something to work with here. That was one of the nice things about Sony with the Beta series, is that a lot of the parts like this were interchangeable from one model to the next. They didn't changed them much. You had units that had 2 heads, you had 3 head units, and there were even a few 4 head units. Some of the high end ones were 4 heads. So we've got the stator assembly back on. Put my spacer back in. And I'm just thinking maybe I should. The glue that goes bad isn't all black like it was on the other one. This one here is this looks to be okay. I think they changed the type of glue that they used, and on the newer ones it didn't go bad as badly as it did on the older ones. I just got to get my spacers and stuff in here so that there's enough clearance. Okay, I've got the spacers in place. Tighten down the nut that holds it in place. We want to make sure that the drum spins freely, which it does. Okay, don't want any rubbing. I don't hear any rubbing there, so that's a good sign. Okay, I've got the drum back together. Get this old unit out of the way here. I have a feeling that that other machine's going to be headed to the scrapyard when I'm done. I've now picked off the video head to fix the other machine, and now I picked off the drum motor, the stator rotor assembly to fix this one. So now we just take the video head assembly and we're just going to drop it back in. So it just drops through the chassis, the wires go down through the hole in the chassis, and somehow, if we can get these wires to go through, we can remount the drum. Carefully not touching the heads against anything. The drum slides in to place. It only goes in one way, so we kind of have to work at it here to get it lined up with the holes. Oh, my wires are in the way, that's why. Wires have to come up through this little, there's a little cutout here for the wires. And once they're in the right place, they should slide in. The wires go up like that. There we go, and the drum assembly just goes in. Just like that. Now we have these big spring-loaded screws that hold the unit in place. The reason that they've got these spring-loaded screws is so that the drum is held at a constant, it's basically floating, right? But it's held at a constant torque. Doesn't matter how tight you do the screws up, they only go in so far, and the springs are actually what holds it in place. So it's like almost having a floating head assembly, because even when the screws are tight, there's always a certain amount of play. Not much, but it does allow the drum to float slightly. Okay, so now we can take our wires and we can reroute our wires back up to the other side of the chassis and plug them into the appropriate connectors. Actually, this one plugs in over here. I was going to feed it to the top side thinking it was like the other machine, but this one here, the head amp's actually on the bottom. So this one plugs in over here. That's the video heads, and the wires tuck in underneath these wire clips. The other two lines, one of them is the FG servo and the other one is the drum servo. They go up top to this other circuit board, and tuck the wires down in behind the clips here. And plug the plugs into the appropriate connectors. This other one, where did it go? It went over to this one. Okay. We've now plugged in the drum. And we've replaced it. But we're not out of the woods yet because I still have to put this other assembly back on here that I had to take off in order to remove the drum. I had to take this piece off, and this is actually a fairly critical part because it holds the tape guides in place as the tape threads up. So we have to put this piece back in, and it kind of goes on like this. I think it's been a long time since I've taken one of these things apart. If I don't put this thing in and I try putting a tape in it, we'll have plastic parts flying all over the place because this is what holds the it goes on like that, I believe. Yeah, that's how it goes up, just like that. That's what holds the tape guides in place. I don't know if you can see that or not, but that's this piece here. This ground that grounds the head drum, but it also has these two plastic guides that hold the tape in place, hold the guide pins in place. So it goes on there like that, and then there's two screws that go through and hold the guide posts. I think that's in the correct way. We'll find out when I plug it in. The moment of truth. Is this thing going to thread properly? Or going to have guideposts flying all over the place? Looks like my guideposts are working. Looks like my drum is spinning. Gee. Rewind this tape a bit. I don't know if I got a picture or not on this thing. We'll find that out pretty soon. I'll just gotta plug it in here. And we have a picture, but our speed is not correct. Yeah, our drum speed is not correct. Sounds like it's going fast, actually. It is. So we have no speed control. So now I have to determine why we don't have any speed control. Oh, maybe I plugged that into the wrong place. Ah, ha, ha, ha. That does it every time. Might help if you plug the bloody servo into the right connector. You guys didn't see that. I didn't have the camera wide enough. I had my drone servo plugged in over here. It actually goes in over to here for speed control. That solved that problem. I was looking for the tracking control on this thing, and you want to see it? It's awesome. It works. It works great. Look at that. Tracking works. This is supposed to have perfect slow motion or perfect freeze frame. Now there's an adjustment for this. Where is it? There's an adjustment on this thing for the still mode. Just gotta find it on the back. I know there's an adjustment on these machines. You just have to find it to adjust the vertical stability when you're in freeze mode, because I'm getting a little jitter. It might not show up on here, but there's some jitter. I'm just going to look for that control. Okay, so we're going to put the thing together, this unit together, and put the screws back in it. This is actually an incredibly heavy machine. I picked this thing up here and couldn't believe how much this thing weighs. This machine here probably weighs like 30 pounds. It's all metal, right? Not like the plastic VHS machines that we saw in the last couple of years before VCRs disappeared. This thing here is built like a brick, you know what. Very, very well built. I mean, Betamax were the better units. They were superior to VHS, and it was just really, it was bad marketing on Sony's part as to why the beta format never survived. There we go. Rewinding the tape. I guess I could make a test recording here too. Yeah, I can make a test recording right on top of his TV guide there. Let me just hook up my house cable here and we'll make a test. Okay, I've got my house cable hooked up. I have a few in-home channels here, not too many. I'll put one off my media player just so that YouTube doesn't get upset. Record. Hit the record switch. And the unit goes into record. I think I've explained before how my system here is set up. I don't have any cable TV here. What I do have though is I do have IPTV, and I have an antenna on the roof. And the antenna on the roof feeds my high definition TVs directly. I also have it feeding a series of converter boxes so that I can have my local channels in standard definition fed out throughout the entire house and into my workshop. So into my workshop here, all I've got is I've just got a coaxial cable. And I've got my house cables. I've got my XBMC media player on channel 4. And I've got some off-air stuff on 5, 7, 9, 11, etc., etc. So I'm just playing back a recording here on my XBMC media player. Just a concert that I downloaded off of YouTube. So this is actually a Raspberry Pi that's outputting this into a stereo modulator, but it doesn't matter because this isn't a stereo machine. Yeah, and I know there's a bit of noise on it. That's just a bad cable in here. So let's stop this and rewind it. We'll go into beta scan back. There we go. Play it and on rewind beta machines you could have a picture because the tape stayed loaded. Okay, go forward a bit. There we go. So here's what I just recorded. Looks great. Tracking is good. This machine is not even a beta high, or not even a super beta. This was just a beta hi-fi. So super beta came after this. But it's working, it's recording and playing. Looks great. One last look at this SL HFR50 Sony Betamax hi-fi ready, all built like a tank. Look at this nice big heavy duty iron core transformer power supply, no switching power supply in this one. Good big heat sinks and regulators in here. This thing just built like a tank. I love the old tuner. For any of you who remember these things. The good old voltage synthesized tuner. You had 14 presets and you could tune them to any channel, but you only had 14. You had to select your channel number and you had to go into channel set and you had to pick your band, VHF low, VHF high, or UHF, and then scan up and down through the channels. Yeah, that was something else. You know, that was great, and people would have, you know, they have them hooked up to cable and you tell them, well, you can only pick 14 channels. And they say, yeah, but I've got 50 channels, you know, 50 analog channels on my cable. Okay, then you got to pick the 14 channels that you'd like to make your recordings from, because you got to remember when you're setting up your timer, right? You can't use a cable box because it's not going to be able to change the channel on the cable box. And yeah, the old voltage synthesized tuners. Yeah, that certainly made a lot of people happy. Another reason why Sony shot themselves in the foot with these machines. A voltage synthesized tuner, and what year would this one have been? This would have been early 90s, I think. Late 80s, early 90s, somewhere in there. I'm just looking for my top cover, which I have right here. We'll just eject that tape. There we go. Put the top cover on. Look at that. It's still got, I like this, cable compatible, 132 channels. Yeah, good luck. Look at the remote control, a picture of the remote control, okay? Yeah, 132 channels, but you can only set 14 of them. You know? Yeah, Sony they shot themselves in the foot with this voltage synthesized tuner. Great unit, other than that, and the fact that it's Betamax. But then who knew, right? Back then Beta was still you know, doing relatively well in the market. But anyway, now you know how to troubleshoot the drum servo circuit on a Betamax machine. And what the problem ended up being on this, I initially thought it was going to be the Hall sensor, which is this little device here. The glue on here gets conductive and starts to short out, and it may be the Hall sensor that's bad. I cleaned all the glue off, but it may have damaged the internals of the IC, or the internals of the Hall device. But I kind of think it's the IC. Capacitors tested fine. The electrolytics, there's no ESR problem with them. They tested just fine. I kind of think just the way it was acting, it's either the IC is gone or the Hall effect device is not sending the signal to the IC to make the switch. I didn't bother to get the scope on it. That would have meant reassembling the whole thing. And when I was turning the rotor by hand, I could hear something dragging. So I thought, well, if something's dragging on here, we're going to have a problem. So because I had another Stator rotor assembly in a machine that's basically scrap because the video head is shot, it made more sense to pull this piece from the other machine and swap it out. Even though these units aren't really meant to be swapped out, the parts were the same, they fit, and it works. So there you go. That's how you fix a Sony Beta. Till next time.